Hello, welcome to the Maths Matrix and part 6 in the percentage series. My name's Rebecca and in this video we're going to be doing mixed exam style percentage questions. Because there's so many types of percentage question and they're all done a bit differently from each other, it's important that you can tell them apart in exams. In this video I'm going to go through some worksheets with you so you can practice doing that. You'll need paper, pen and a calculator, and you'll need to know how to do all 7 types of percentage question. Let's get started. This is the first page of questions, and if you want to have a go at them entirely on your own, then you can just hit pause now and have a go at them. And I'm going to put worked solutions on at the end, photographs of worked solutions like I do in my usual videos. So if you think that you can do them without any hints or help, then just have a go and then check the solutions at the end. There's going to be another 2 sheets of questions besides this one, so you'll have to skip forwards in the video to get the second and third sheets, and the solutions to all of them will be on at the end. If you think you need a hint, just hit pause and have a read of the first question, and then when you're ready, hit play and I'll give you some hints. Now this first question is a reverse percent question because it's telling us that something costs £60 now and it's asking us what did it cost before. So because it's asking us to look back in time to what something was before, we know we must have a reverse percentage scenario. So that means this is a type 7 reverse percentage and we have to start by asking ourselves, what percent do I have here? So if that's enough of a hint for you, then hit pause now and have a go at it. If you're still not sure, because it's 20% off, that means that we only have 80% left. So 20% has been taken off the price, which means 80% is left. So the answer to what percent do I have here is 80% is what I have here, and that is £60. Okay, so that would be your first line of working. We would then need to divide down to a chunk that will fit into 100. So if I divide 80 by 4, that'll give me 20%. And so I need to divide 60 by 4 as well to keep the 2 sides balanced, which would give me £15. And if 20% equals £15, then I can times that by 5 to give me 100%, which means 100% would have been £75. Looking at the second question, this is asking us what was the percentage increase. So this is giving us 2 different numbers and it's saying what percentage increase has already taken place. So this is going to be a type 6. So this is one of those where we have to do actual change over original value. And we have to either express that as a percentage if we're doing it without a calculator, or times by 100 if we're doing it with a calculator. Okay, so if you think you know now how to do that question, then hit pause and have a go. And if you're still not sure, I'll go through it in some detail. So the actual change is going to be 825 minus 750, which is 75. So the actual change has been 75 pupils because it's gone up from 750 to 825. So using actual change over original value, the original value was the one that was there first, so 750. And we then need to express that as a percentage. Now that will cancel down to 1/10. And 1/10 is 10%. So the percentage increase that occurred was 10%. If you were working on a calculator, then you would do 75 over 750 times 100 into the calculator, and that'd give you the same 10% answer as before. All right. Looking at the third one. This is a compound interest scenario because it says we have a percentage being applied per annum, so every year. So this much money is being invested in an account that pays a certain percentage increase every year, and we're being asked what will there be after 4 years. So this is compound interest, which is also called exponential growth or decay, which is also called repeated percentage change. If that's enough of a hint for you, then pause and have a go. If it's not, keep watching. And what we would do here is we would use the formula original amount times by multiplier to the power period of time. So that would be a type 4. If you went through the videos and made the notes, this was a type 4 question. So because interest is being paid at 3%, 100% plus 3% is 103%, which as a decimal is 1.03. So that's what we would use as our multiplier. So we would have 1200 is the original amount times by the multiplier 1.03 to the period of time 4 years. And that would then just go into the calculator. So we would have 1200 times 1.03. And then on my calculator, you press that little X with a square to give you a power. And in there we would put 4 for the period of time, and then we would just press equals. And that gives us 1350.61 to the nearest penny. Okay. Then looking at that bottom question, here we're being told that something costs £45 before VAT is added, and we're being asked how much will it cost after VAT is added. So this is just a straightforward find 20% and add it on to 45 scenario. So this is just a percentage increase question, which would be a type 2, okay? And it could be done both with or without a calculator. So I'll do it without a calculator. So 10% would be £4.50. So 20% would be twice that, which would be £9. And then we need to add that on. So £45 plus £9 would equal £54. And that would be the final answer. Okay. If you were doing it with a calculator, you'd use 120%. So you'd need all of the 45 plus an extra 20%. So you'd have 120%, which is 1.2 as a decimal. So you'd have 45 times 1.2 would go into the calculator, and that would give you the same £54 as before. The second sheet of questions is here. So if you think that you would know how to do all those, if you want to test your knowledge with no hints at all, then just hit pause and have a go at them. Then go to the end of the video where there'll be a photograph with the solutions. If you need some hints, then we'll get started with those. So the first question says, a shirt costing £35 is put into a 15% off sale. What is the sale price? So we're being told this is the old. What will the new price be? So it's just straightforward forward percentage. It's not reverse percentage because we're not being asked to look back in time. We're being asked what is the new, what is it now? And so again, this can be done either with or without a calculator, but we're being asked to find 15% of 35, and then because the shirt's on sale, it's going to cost less, so we're being asked to subtract 15% from 35. So without a calculator, 10% would equal £3.50. So 5% would equal half of that, which would be £1.75. So those could then be added together to give 15%, which would be £5.25. And then because it's a 15% off sale, we would then do £35 minus £5.25. Well, 35 take 5 is 30, and take 25p would be 29.75 as our final answer. Doesn't matter if you can't do it that quickly, if you need to do more arithmetic off to one side. On a calculator, if we have 100% of the price and we subtract 15%, that means there's only 85% left, which gives us a multiplier of 0.85, and 35 times 0.85 would give us the same 29.75 as before. We'd just put that into the calculator. If this is moving too quickly for you, then it means you're not ready to do these kind of revision questions yet. It means you need to go back and watch the previous videos in more detail and actually get good at the foundational work first. So this is just really designed as a can you identify what type of percentage question you have practice, and a speedy revision. This is not to learn percentage from scratch with, all right? Let's have a look at the second question. So this says, every hour the number of atoms of a radioactive substance decreases by 50%. If there are 100,000 atoms to begin with, how many will there be after 4 hours? Now this is a little bit tricky because it's not in a very familiar context, but this is compound growth and decay again, or repeated percentage change, because we're being given an original amount. We're being given a percentage that is applied every hour and asked what will there be after 4 hours. So if that now gives you the hint that you need, then feel free to pause and do the question. If not, then we're going to use the formula original amount times by multiplier to the power period of time. Now, our multiplier, we have decreases by 50%. So if something was 100% and then it decreases by 50%, that leaves us with just 50%. So there'll only be 50% left every hour, which as a multiplier is 0.5, as a decimal, is 0.5. And that's what we'll use as our multiplier. So we have our original amount is 100,000 times by our multiplier, which is 0.5, to the power period of time, which is 4, and that would just go into the calculator. So 100,000 times 0.5 to the power 4 equals 6,250. Exactly. Looking at the next question, we're told there are 750 pupils in a school, and by 2018 this number is predicted to rise by 12%. How many pupils will there be by then? This again is just a straightforward forwards percentage question. It's just saying this is now. What will there be after a 12% increase? So it's not reverse percentage, it's just forwards percentage, and we're just being asked to find 12% and then add it on. So if that's enough of a hint, then you can do it now. And if not, then we have 10% equals 75. So 1% equals 7.5. So 2% equals 15. So 12% would equal 10% plus 2%, which would equal 90. And then 750 plus 90 would equal 840, would be the new amount. And that's without a calculator. If you wanted it with a calculator, then 100% plus 12% equals 112%, which is 1.12. And 750 times 1.12 would give us the same 840 pupils as before. Looking at the last question on this sheet, Sarah gets 37 out of 44. Express her result as a percentage. So here, we're not being asked to find a percent. We're not being given a percent and asked to find that percentage. We're being given two numbers and asked to express one as a percentage of the other. So this is a type 5 question. So we have 37 out of 44, which we're being asked to express as a percentage. Now 44 doesn't really chunk down nicely without a calculator to something that would then itself fit into 100. We can't bring it down to 10% or 20% or 5% or anything that would nicely then scale up into 100. So this would just be a calculator question. In an exam scenario, it would be on a calculator paper, so you'd know. So we would just put the fraction into the calculator and then times it by 100. So you can either use your fraction button, which is on my calculator, the square with the line and the square, or else you could use a divide. I'm just going to go with a divide because it's quicker. So 37 divided by 44 equals, and then times 100 equals, and that's giving us 84.09 recurring, so 090909, which would be, I'll just go with 84.1% to 3 significant figures. All right. The final sheet of questions is there. So if you want to have a go with no hints at all, then just hit pause and then check the solutions at the end. If you don't think you could do it without hints, then we'll get started on those. So the first question says a student's exam result is 14% higher than in his mock. He gets 250 marks in his exam. Assuming his exam has the same number of total marks available as his mock, what was his mock mark? Okay. So we're being asked here to look back in time. What was his mock mark? What did he get before? So because we're being asked to look back in time, this is a type 7 reverse percentage. So if you now think that you could do it, knowing that it's a looking back in time scenario, then hit pause and have a go. And if not, then your starter question is what percent do I have here? Okay. So because he's getting 14% more in his exam than he did in his mock, that means he's getting 100% of what he got in his mock and another 14% as well. So we have 114%. So the answer to the question, what percent do I have here, is I have 114% equals 250 marks. All right. Then this would be a calculator based question, which on the exam you'd know because it would be on your calculator paper as opposed to your non-calculator paper. So I'm just going to scale it all the way down to 1%. So 250 divided by 114 equals 2.192982 ... So 100% would equal 100 times that, which is just 219.298 ... And then I'll go with a whole number of marks, so we'll make that 219 marks as our final answer. All right. And that does make sense because we're told he does better in his exam than he does in his mark. And according to our figures, he's got 250 in his exam, but he only got 219 in his mark. So his mark has indeed gone up from his mark to his real thing. And so we have done it the right way round. We have moved in the right direction. So with reverse percentage questions, it's often helpful to just check at the end, have things moved in the right direction? Does your answer make sense in context of the story? Okay. Now the second question on this sheet is intentionally very similar to the one that's just come before. So this time we're told a student gets 147 in his mark. He needs to increase this mark by 14% to get the grade he wants in his exam. How many marks does he need to get in his exam? Now the other question said this is what he's got in his exam. Look back in time. What did he get in his mark? So it was a backwards reverse percentage question. This is the exact opposite. This is saying this is what he gets now in his mark and he needs to get something different in the future. So this is just forwards percentage. And all this question is saying in a roundabout way is find 14% of 147 and add it on. So if that's enough of a hint, then get on and do that. Now we have 100% plus 14% equals 114%, which equals 1.14. So if I times 147 by 1.14, that will increase 147 by 14%. So 147 times 1.14 equals 167.58, and I'll just round that up to the nearest mark. So 168 marks. Okay. This one would probably be on a calculator paper. The numbers aren't nice, so I'm only going to do it with a calculator. I'm not going to do the non-calculator version for that one. All right. And then the final question. In a town, 653 people were unemployed in 2013. By 2015, 527 were unemployed. Calculate the percentage decrease in unemployment. So if you think you know how to do this, then have a go. And if not, this is actually telling us in the question really what the topic is. It's saying calculate the percentage decrease. So this is not giving us a percentage and saying find that percentage. It's saying what is the percentage. So this is a type 6 question. It's a calculate the percentage increase, decrease or change scenario. So we're going to be using actual change over original value expressed as a percentage. So either expressed as a percentage by scaling up the fraction or by timesing 100 if it's a calculator thing. Okay. So the actual change is going to be 653 take 527. So that is 653 take 527 equals 126. So the actual change is 126, and on an exam that would usually get you a method mark, that subtraction. So I will now put 126 over the original value, which is 653, because that was the earlier of the two values given. This is too difficult to do without a calculator, so it would be on a calculator paper. So it would just go into the calculator like that. So 126 divided by 653 equals times 100 equals, and that's 19.29555 ... So I'll call that 19%. Hopefully you found that useful, looking at lots of different percentage questions one after another. It can be tricky at first trying to figure out what type of percentage question it is you've got. In general, if you're working out something now, if you're using an old thing to work out a new thing or to find out what something is now or will be in the future, then it's a forwards scenario. So you're usually in those cases being asked in a roundabout way, find a percent and add it on or take it off. So it's usually percentage increase or percentage decrease. If you're told that a particular percentage is going to be applied again and again over a certain amount of time, so every second or every minute or every year, then that's a repeated percentage change scenario. So that's a type 4, and that's where you'd use the formula original amount times by multiplier to the power period of time. Those are generally quite easy to spot because it will have to allude in the question to the fact that something's happening over and over for a certain amount of time, so they can be quite easy to spot. Reverse percentage are the ones where you're being asked to look back in time and work out what something was before or what an original value was. And if it's none of those, if nowhere in the question is there actually a percentage sign, so if it doesn't anywhere in the question say, for example, 10% or 15% or 25%, but rather is asking you to calculate the percent or calculate the percentage change or calculate the percentage increase or decrease, then it must be a type 5 or 6. So you kind of get to type 5 or 6 really by process of elimination if there's no percentage symbol anywhere in the question. Really the only way to get good at discovering which type of percentage question you've got is to just practice lots of percentage questions. So it's not something that anyone can do straight away. Really, the more practice papers you do, the more tests at school you do, the more past papers you see, the better you'll get at it. But hopefully going through a range of exam style questions all together like that one after another has been helpful for you. If you did find the video useful, please consider subscribing to the channel or leaving me a thumbs up, and I'll see you next time where we'll be doing a whole new topic. Thank you.